Alright, here we go. So this is the lesson for 2.6. This is the last lesson of chapter 2. Alright, so what we're talking about today is what's called a least squares regression line. Very similar to the last lesson, 2.5, where we just basically talked about what a regression line is. So what we're going to talk about today is what a least squares regression line is, and then how outliers affect regression lines. Alright, so our one vocab word is just called a least squares regression line. That just means if you were to take a regression line and make it as accurate as possible, we call it a least squares regression line. Or if you were to take all the residuals and make them as small as possible, that's what a least squares regression line is. Alright, so it's actually all regression lines that we basically are figuring out using that app or the website Statplet.com. That's a least squares regression line. Alright, so also, the other thing I wanted to mention was how outliers affect regression lines. Alright, so I drew just an example here. This isn't on your notes, but this is just kind of something to look at. Right here I have a scatter plot, and if you look at this, it's pretty moderately strong for the strength. If I were to draw a line of best fit or a regression line, let's actually draw this in red. If I were to draw a regression line, it would probably be about there, right? That line goes through most of those points, or as close as possible. But let's say I added another point. Alright, I'm going to add this point in green. Let's say I added a point down here. Alright, this would definitely be called an outlier. Alright, now what happens, now we got to figure out what happens to the line of best fit or the regression line, knowing that the outlier gets added. Alright, so we got to figure out what happens to that regression line or that line of best fit if we add that outlier. Alright, so what happens is, think of that line as kind of like a seesaw. You know what a seesaw or a teeter-totter is another name. Think of it that way. Think about this line. If I were to kind of let's draw another line like this, and think of it as it's kind of getting that doesn't work. Let me just draw another line. If we were to draw another line of best fit, think of that line kind of getting pulled towards that outlier. Alright, so instead of going this way, that line of best fit kind of gets pulled down towards that green outlier there. Alright, so what I'm trying to say is if you add an outlier to a scatter plot, the line of regression changes. Alright, and there's two things you gotta look at how it can change. One, look at what happens to the slope. Alright, it goes from this down to this. Alright, and the vocab we use is does it become more steep or less steep? Alright, it goes from this down to here. So what happens if we add that outlier? It becomes less steep. And then also the other thing we gotta look at, what happens to the y-intercept if we add that point? Well, it goes from down here up to here. So what happens to it? It increases. Then the other question you might get is what happens to the correlation? What happens to the correlation if you add that green point? And what happens is that correlation weakens. It gets close to zero. Is another way to say it. Alright? Because all the dots or the points, data points, were all pretty close together until that green point was added. It just weakens the correlation. Doesn't make them all as close together as they were before the outlier. Alright, so that's really all we wanted to cover from this lesson. Every other lesson, we'll go over some examples when we get in class. Alright, that was it. That was 2.6. Thanks for watching. Peace.